Okay, hey guys, I'm Akhil, and I'm going to be going over the background info on how to set up determining the enthalpy change associated with the chemical reaction. So what we have to do is we have to measure the temperature change of the reaction between solutions of sodium hydroxide and phosphoric acid. But in this case, we don't have phosphoric acid to deal with, so we'll be using acetic acid. We also had to calculate the enthalpy of neutralization of acetic acid. And the enthalpy of neutralization is the change in enthalpy that occurs when one equivalent of acid of a base and one equivalent of an acid undergoes a neutralization reaction to form a water and a salt. It is a special case of the enthalpy of reaction and is defined as the energy released with formation of 1 mole of water. We also had to compare a calculated enthalpy of neutralization with the accepted value. So pretty much we're just going to mix the two solutions together, hello Lance, and see the temperature change.
Hi guys, I'm Lance. Today, hey John. Today I'm going to be going over the materials you need to do this lab. Hi Zena. Material number 1. Safety goggles. Most important thing, actually. Make sure you got those on. You're working with some dangerous chemicals. Alright, so first you want to have your graduated cylinder to measure out your sodium hydroxide and your acetic acid. And acetic acid. Then we're going to move over here. We have our data collection mechanism. It's a spark. You're going to use a spark to collect the data. You got your temperature probe attachment. It goes in the top right there. You got your calorimeter. Opens up. Put the reaction inside. You're going to put the temperature probe right here, and you're going to measure the temperature. And that's all the materials you're going to need for this project. Lab. It's called lab. Go.
Throughout the procedure, make sure to stir the solution ever so gently to
Well said.
to proceed with the reaction. Hi guys, I'm Nadir.
Hey Nadir.
So to actually run this experiment, we're going to take our 0.6 molar acetic acid solution and I'm going to add it to the calorimeter with the temperature probe attached to the clamp like this.
Oh wow.
Okay, and then once we have that in there, make sure the temperature probe is touching the solution, and then we're going to build a temperature versus time graph. And so the way you do that is with the temperature probe connected, we're going to click build.
I guess I can't cover your face.
You're going to click temperature and time. You're going to go graph.
Literally zoom in. You can't see it though.
So we have a temperature, time, and build a graph. I'm going to click OK.
Okay.
And then we're just going to start it just to get an initial temperature reading.
Oh, interesting.
Once we have that, we're going to add the 1.85 molar NaOH solution.
Make sure the temperature probe is in the liquid, but not touching the bottom of the calorimeter. You didn't say make sure it's not touching the Make sure you get all of it in there. You don't want any drops left. It's ruin your experiment.
Alright, and once it's all in there, we're going to close it up and watch the spark. Alright, so ideally you're going to want to keep this going for 10 minutes. For instructional purposes, I've stopped at 2 minutes, but basically you're just going to press the play button again to stop the data collection. And then what the data you're going to want to collect is the maximum temperature and the initial temperature. And the way you do that is you're going to go click on this little graph button. We're going to zoom it in first. You see that temperature change. We're going to click this little sigma button right here. We're going to click minimum and maximum. We'll click OK. So we now have our min and max, 22.7 and 28.2.
Yeah.
And so we're just going to record that in our data table, take the difference, and run it another 3 times for 3 trials. And that's about it.
Hi, I'm Jonathan. In this lab, we measured the temperature change of the reaction between an acid and a base. The acid was acetic acid and the base was sodium hydroxide. We calculated the enthalpy of neutralization of the acetic acid and we compared our calculated enthalpy of neutralization with the accepted value to find a percent error.